Before we go to the concept of credit card fraud detection model, let me tell you something very interesting, that how machine learning is applicable to real life and what is the interpretation of machine learning in real life. Let me tell you a very simple story. Okay, what is the simple story? Suppose there is a doctor. And there is a patient. The patient came to the emergency. And what are the symptoms of the patient? The patient has multiple symptoms. What are the symptoms? The symptoms of the patient are one side of the body of the patient is not working. He is not getting any type of stimulus in one part or one side of the body. Okay, that is the first symptom. The second symptom is the patient is unable to talk properly. The patient is unable to talk properly. The third symptom is the patient is feeling dizziness. The patient is not feeling well. The patient is feeling dizziness. So now when the doctor sees the patient in the emergency and finds out these three symptoms, what will the doctor do? The basic thing, or the first thing that the doctor will do, the doctor will predict. The doctor will do what? The doctor will predict. What? The doctor will predict the disease. Or doctor will predict the condition, that what has happened. Predict the condition or predict the disease. So what prediction the doctor will make? The doctor will make the prediction. The doctor can make many predictions, but as per the symptoms, the doctor will make the prediction that the patient is suffering from stroke. Right? Now, this is a prediction done by a doctor on the basis of the symptoms. These are the symptoms 1, 2 and 3, that the patient is feeling dizziness, patient is not getting any stimulus in one part of the body, and the patient is feeling the patient is unable to talk properly. On the basis of these three symptoms, the doctor is providing a prediction, and that prediction is stroke. Okay, and let me say that the doctor is 20 years. The doctor is holding 20 years of experience. 20 years of experience. Now, that prediction can be right, can be wrong also. The prediction that the doctor has made that the patient is suffering from stroke can be right or can be wrong also. But in most of the cases, we will find that the prediction of the doctor is right, and rightly the patient is suffering from stroke. Now, in our case, in machine learning, symptoms are basically data. Symptoms are basically data. On the basis of that, what was the doctor doing? The doctor was predicting the condition on the basis of the symptoms. The doctor was predicting the condition or the disease on the basis of the symptoms. So, in our case also, in machine learning, in the context of machine learning, symptoms are basically data. You have to predict the results on the basis of the data. Can anyone tell that in the case of the doctor, if the doctor is highly successful in predicting the conditions, then he might be experienced? That means we can make a general consensus that experienced doctors are more fluent or more capable of predicting the condition or disease. If a doctor having 20 years of experience, he will obviously predict the disease more accurately than a doctor having only 1 or 2 or 3 years of experience. So, the accuracy of the doctor's accuracy is depending on what? It is depending on the experience. It is depending on the years of experience of the doctor. Similarly, in machine learning, whether our data will give us good result or not, whether our data will predict the outcome properly or not, depends on the size of the data. Size of the data. So in the case of the doctor, who was important? What was important? It was the experience of the doctor which was important, which was making the doctor to predict more successfully. But in our case, what is important? the size of the data is important to predict the outcomes properly. Okay, so in this way you can actually relate real life problem with machine learning. Okay, so just like the symptoms, in our machine learning, data is the symptom, and just like the experience of the doctor, size of the data is very key or very important to predict the outcome. And at the end, with the help of this data, we will predict the outcome. Just as the doctor has predicted the disease with the help of the symptoms, we will predict the outcome with the help of the data. Now that outcome can be true, that outcome can be false. But if we have huge amount of data and we have fitted proper modeling, then our prediction in most of the cases will be true or will be accurate. In most of the cases, our prediction will be accurate and perfect. Just like if an experienced doctor visits a patient, in most of the cases, the prediction of the doctor is accurate. Right? So, in this way, you can actually relate machine learning to the context of real life. Now, today's scenario, the class of today is dedicated to credit card fraud detection modeling, where we have this data. Let me show you the data. This is the data that we are going to work with today. We have multiple variables in this data. We have amount, we have transaction hours, merchant type, online transaction, international transaction, last 24 hours, average amount of last 30 days, failed attempts, and fraud. I feel that most of you are feeling quite anxious about the details of these variables. That what is the details of these variables. So that's why we have prepared a PDF containing the details of these variables. Okay. So let us go to the details of these variables one by one. Then we will discuss about the model fitting in Python. So this is the snapshot of the data which I have shown you. Now we are going to part of the variable information. First variable is basically transaction ID, which is not a necessary variable in our analysis. It is just used for identification. This variable transaction ID will not be used in the analysis. From the second variable, it is important, amount. Amount is a quantitative variable. What does it tells? It tells total monetary value of the transaction. If the amount is 500, that means that 500 rupees was being the amount of transaction on that particular time. Okay. Transaction hour. Transaction hour is basically hour of the day when the transaction occurred. If the transaction hour is suppose 3, that means the transaction had occurred at 3 a.m. If the transaction hour is suppose 18, that means the transaction had happened at 6 p.m. In this way, the transaction hour is measured. So I hope you are getting the idea of this first variable, amount. What does this 873 means? It means the amount of transaction was 873 on that time or on that particular trial. On the second variable, transaction hour is 1. Transaction hour is 1. What does it means? It means that the transaction occurred at 1 a.m. Okay. Next is merchant type. Merchant type is the next variable. What is merchant type? Merchant type is basically a categorical variable. It gives us that the transaction took place by which medium. Is the transaction done in grocery, or the transaction done by the consumer in electronics, or in travel, or luxury, or fuel, or clothing, or restaurant? So that is the merchant type. Last, fifth, online transaction. It is also a categorical variable. Online transaction are basically that if the transaction was done in online mode, then it is 1, and if the transaction is done in the offline mode, then it is 0. International is also a categorical variable. International variable is measured on a dichotomous scale. It has only two values, 1 or 0. 1 means it is an international transaction. 0 means it is a domestic transaction. Seventh, last variable, we have another variable, transactions in the last 24 hours. it describes number of transactions made using the same card in the last 24 hours. Number of transactions made using the same credit card in the last 24 hours. So if I go to the Excel file, as you can see, transaction in the last 24 hours is 2 for the first transaction ID. That means in the last 24 hours, this transaction ID or this individual had made 2 transactions. For the second transaction ID, he has made 3 transactions in the last 24 hours. For the third, he has made 4 transactions in the last 24 hours. Okay. For the international also, what does this value of 0 interprets? It means that it was not an international transaction. What does this 1 interprets? That interprets that it is an international transaction. Average amount in last 30 days, it describes the average transaction amount of the cardholder over the last 30 days. And failed attempts, it is a very key indicator. Failed attempts means multiple failures. How many times the card is being used but the payment has failed. The payment can fail due to a wrong PIN or wrong OTP or internet connectivity, anything. But number of times the payment has failed. This is being shown by this variable called failed attempts. Now if I go to the Excel file, for the first transaction ID, failed attempts is 0. Second is failed attempts is 0. That means there was no failed attempt in this transaction of 946 rupees. But as you go to the third, the failed attempt is 3. The failed attempt is 3. That means when this transaction happened of 1019 rupees, there was 3 failed attempts. There was 3 failed attempts. Can anyone out of you tell me that can this third transaction, can this be a fraud transaction? Because if I am holding my credit card, will I make 3 failed attempts by any chance? If I am using my own credit card, will I make 3 failed attempts?
No, sir.
Obviously not. So might be someone else with my credit card without my permission is trying to swap my credit card and get the money out of my credit card. So this might be a fraud transaction. And can you see the last variable, that is fraud? Let me just show you. Fraud is basically measured on a dichotomous scale. It is going to be our dependent variable also. It has 2 values, 1 if it is a fraud transaction and 0 if it is a genuine transaction. That means it is not a fraud transaction. So again we can see from our data that in the third row or in the third value we can see it is 1. That means it was a fraud transaction. It was what? It was a fraud transaction. So I hope you have a proper idea about the data now. Is there any doubt regarding the concept of the variables? If don't, then we will move to the coding part and create a model by which if you give these values, the model will predict you that whether it is a fraud transaction or it is a genuine transaction. That means in that model you have to give the amount of transaction, you have to give transaction hour, you have to give merchant type, online transaction, international value, last 24-hour value, average amount last 30 days and failed attempt. If you give all these values, the model will predict you that whether the transaction was fraud or a genuine transaction. We will create that model in Python, but just let me be clear with it that have you obtained the idea properly about the variables?
Average amount of last 30 days and the transaction hour. Not clear.
Average amount of last 30 days on the transaction hour, it is basically on the last 30 days it is added. For the last 30 days total transaction was added, then it was divided by 30. Okay, so if we take an example of the month of January, then for the 31 days of January, all the daily transactions of that credit card was added and then it was divided by 31.
Okay, so what about transaction hour?
Transaction hour is basically on which hour the transaction has happened. If it is 1, that means it has happened at 1 a.m. If it is 10, that means it has happened in 10 a.m. If it is 23, that means it has happened in 11 p.m. Okay, in this way it is measured, 1 to 23. Okay, tell me, any doubt in this?
The merchant type check.
Okay, merchant time I will clear. If it is 14, transaction hour is 14, that means the transaction has happened in 2 p.m. 2 p.m. If it is 16, means it has happened at 4 p.m. In this way it was measured. Okay?
Sir,
Yes.
if the month have 28 days, so in average amount last 30 days, total amount is divided by 28 or 30.
28, obviously.
Okay.
Merchant type is basically where the transaction was made, whether the transaction was made in a purchasing of electronics, or in the restaurant, or any type of luxurious item buying, or fuel, or travel, or clothing, etc. Clear? Clear?
Yes, sir.
Okay, let me change this name, average amount of last month, so that it will be appropriate. Last month. Okay, now we will go to the coding part and we will create a model, and on the basis of the model, if you feed all these inputs, you will get an output that whether the transaction is fraud or genuine. So let me go to Jupyter Notebook, and after going to Jupyter Notebook, I have sent a video in the group where we have shown you that how to install the Jupyter Notebook in your laptop or PC. So you go through that video and install the Jupyter Notebook. After opening the Jupyter Notebook, at first you have to upload the data. The dataset also is being provided to all of you in the group. So click on this upload option. Click on this upload option. Okay, here in this upload option you have to click. After clicking on this upload option, you have to click on the data set. Here is our data, credit card fraud detection data. So I will click on this data and I will click on open, and the dataset is now loaded. Where to see this dataset? File not uploaded. In my case it will not be uploaded because it was already uploaded in my Python, but in your case it will be uploaded properly. You will be able to see that here is our data, credit card fraud detection data, already loaded in the Python or in the Jupyter Notebook. Now we will go to the coding part. For going to the coding part, you have to click on this new option, then you have to click on this Python 3 IPY kernel. After clicking on this, it will open an interface like this. It will open an interface like this. Let me just load it. Here you have to write your codes. All the codes that you want to write, here you have to write it. Now I have already made this notebook open, so I will go to that, and here I have made some breakdowns of the code. The entire code is not written. I have just the breakdowns of the code so that I can finish it properly and early and in a quick manner, so that we doesn't waste a huge amount of time in writing the code. Here the codes are not written. Let me tell you, whenever in Jupyter Notebook you are writing something and you are giving this hash, okay, before it, then it is not a code anymore. It is not a code. This line will not be executed. Okay, so now we will start our code from here. What is the first thing that we are supposed to do if you are doing coding for the first time in Python? If you are going to run a model or create a model, the first thing that you have to do is to install or import the libraries. You have to import the libraries which are required. So we require 3 libraries. One is pandas, we require train test split, we require logistic regression, and let me just write train test split. We require logistic regression. It is another library that we require. Logistic regression. And we require another library that is label encoder. Label encoder. Now these libraries are not available at a free space. These libraries are basically loaded in a module. You can say these libraries are loaded in a module. So we have to take the libraries from the modules. And then we have to import it. Pandas is not loaded in module. Pandas is a module itself. So we will just import pandas. What is this word import? This is basically used to import the library. If you have to import any library, before the library you have to give this word import. So if we have to import the library train test split, we will again give the word import. If we have to import the library of logistic regression, we will give again write import logistic regression. If we have to import this library label encoder, again you have to write import label encoder. What is the function of all these libraries? You will soon know it. Okay. Then as I have said you, that train test split is not available at a free space. It is stored in a module. What is the name of that module? That module is basically sklearn.model selection. sklearn.model_selection. So we have to import the train test split from sklearn.selection module. This is the module name. sklearn.model selection is the module name, and within that module we have this library train test and split. So we should write from, right? Why is it written from? From is basically written because we are importing train test split. But from where? From sklearn.model selection module. From sklearn.model selection module we are importing train test split library. Same goes for logistic regression. It is not available on a free space. It is available in a module. What is that module? That module is sklearn.linear model. Again sklearn.linear model. From sklearn.linear model we are importing this library logistic regression. From sklearn.linear model module we are importing logistic regression library. So we will just give from before it. And same goes for label encoder. Label encoder is also not freely available on an open space. You have to take it from a library. What is that library? That library is called from a module. Sorry, you have to take it from a module. What is the module name? sklearn.preprocessing. sklearn.preprocessing. These libraries are basically made to make our work easier, so that we don't have to write huge amount of codes. So this label encoder is the name of the library. sklearn.preprocessing is the name of the module, and we are from the module sklearn.preprocessing we are importing the library label encoder. So here we have successfully imported all the libraries which are required. Okay. Now the first thing that we have to do, we have to import the dataset. We have loaded the dataset but not imported the dataset in Jupyter Notebook yet. Have we imported the dataset in this notebook yet? The answer is no. So we will import the dataset in the second step. So what is the command for that? The code for that is you have to write pandas. Pandas is the library which you have already imported. So by using or calling this pandas library, you have to load your dataset in Python. I hope you are getting it now, that why we have imported this library suddenly out of nowhere, because these libraries will be required in the below part to write the entire code. These 4 libraries that we have imported will be required. That's why I have imported this. Okay. So the code is, you have to write pandas. You have to call this library pandas. Then you have to write dot read Excel. You have to write dot read underscore Excel. If your file is not an Excel file, if it is a CSV file, you don't have to write dot read Excel. You have to write dot CSV underscore CSV. But in our case, the file is an Excel file, so we will write read underscore Excel, and then within a double quotation and within a first bracket, you have to give the name of the Excel file .xlsx. So let me write the code. Here all these lines are not code. Why? Because we have this sign before it. We have this sign before it. If we provide this sign before it, before the line, it doesn't remain code anymore. It becomes a normal statement. Now we are going to write the code here. So the first we have written pandas, then rot read underscore Excel. This code is being written to load the data. Now within a double quotation and the single bracket, we have to give the name of the Excel file. What was the name of the Excel file? Can anyone want to recall me? What is the name of the Excel file? Can anyone recall? What was the name of the Excel file that we have loaded?
Credit card fraud detection data.
Credit card fraud detection data. Very good. This is the data, credit card fraud detection data that we have loaded. So we will write credit card fraud detection data. Then we have to provide .xlsx. Why is it provided? Because our data is a Excel file, and in an Excel file, xlsx is the extension. It is the extension. That's why we are giving xlsx. And then we will close the double bracket, double quotation, and provide the single bracket. Now, if we run this code, you will see that the code is being executed. Pandas not defined. Oh, sorry, I haven't run the first line. Let me run all cells. Yeah. So we have executed the code. sklearn.preprocessing. sklearn.preprocessing import label encoder. No module named sklearn.preprocessing. Preprocessing. Is there any? Oh, sorry. Yeah, right. Thank you. Pre-processing, there was a C basically, which was making a spelling mistake. Yeah. So now the code is being run properly. Now we have to store it to a new name. Okay, we have to store it in a new name. Whatever data is being loaded, I cannot recall it by this name every time because this is a very big line of code. So I want to store this data of credit card fraud detection data into a new name. So I will assign it to a new name. What name can be assigned? You can give any name. You can give Dipto, Shayok, whatever. You can name it by your name, whatever. For the simplicity, I am giving the new name as df. And after giving equal to, I will write this entire line of code again. And we have a new name assigned. Okay. So as you can see, I have this written here for you also, that for assigning it to a new name, you have to write the new name, which is df, and then you have to write this code again, pandas.readexcel, and within a single bracket and double quotes, you have to give the name of your Excel file. Now if I execute it, it will be operated. I am not executing it currently. The first thing that you will do after loading your data, you might be willing to see your data at first, that how my data looks. Although I have seen my data in Excel file, but let me see in the Python also that how my data looks, what is the shape of my data. So for that, in the next cell, we are going to see the first 10 rows of our data. First 10 rows of the data. What will be the code for that? You have to give that new name where you have stored your data. Then you have to call .head function. .head. And within a single bracket, you will provide 10 as you want to see the first 10 rows of the data. Now can anyone want to assign me? Can anyone want to help me with this code? What will be the new name that I have to write here? df dot head. Then within a first bracket, I have to provide 10. If I provide 20 in place of 10, it will show me the first 20 rows of the data. Now let me run it and see the first 10 rows of the data. Can you see the first 10 rows of the data? Is this the same data that was being operated by us in Excel file? Okay. Now we are going to see the shape of our data. What is the code to see the shape of our data? You have to give the new name, then you have to just write dot shape. What is the name that we have assigned? What is the name that we have assigned or stored our data in which? Our df, right? Then df dot shape. Just enter it. It is telling 1000 comma 10. What is this 10? Can anyone tell me? Just count the number of columns that we have, or count the number of columns or number of variables that we have. Just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So what is this 10 meaning? It means there are total 10 columns. And what is this 1000? This 1000 is basically referring to the number of rows in our data. We have 1000 rows in our data. Okay. Now we want to see the information of the variables, that what is the data types of our variable. Is the data type integer? Is it a float? Is it a object? Is it a categorical variable? We want to see the information of the variable. So for that you have to again give df, that is the new name, then dot info and then first bracket opened and closed. As you can see, the information of the variables is being shown. Transaction ID is object. Amount is integer. int64. int64 means it is an integer. Transaction hour is integer. int64. Merchant type is object. Why is merchant type object? Just look at the data. What is this merchant type? Electronics, restaurant, fuel. Is this any numbers? Right, this is a categorical variable. This doesn't contain any numeric values. It is not containing 0, 1 or anything. Is it containing integer values or numeric values? The answer is no. It is not containing any numeric or integer values. So it is containing some text. Electronic, restaurant, these are all text. So whenever the text data is present in the values of a variable, it is an object. The data type of the data is object. So that's why merchant type is object. Okay. This 1000 is non-null. Non-null is basically that how many data values are present in the data. So in all the variables we have 1000 values present in the data. So that's why thousands are being shown as per aligned with all the variables.
So basically 1000 is said to be a row.
1000 to be, you can say it is a row. It is basically not row actually. 1000 is here the 1000 refers, it is non-null. Non-null means filled. The points are filled. The data points are not empty. So for the first variable transaction ID, it is 1000. That means there are total 1000 data points. No empty value present. In amount also 1000. That means there are total 1000 filled values present. If there was some empty or null values in our data, suppose we have 2 null values in amount column. We have 2 null values in amount column. You will find in that case this non-null will be 998, not 1000. Because in that case 2 missing values excluded, we have 998 values remaining in the amount column. Okay. Clear? So we have the information of the data types. Now I am just not going into this part because this is not required. Encoding, I am not going into encoding. Yeah, we can do it also here. Let me just go to it. As you can see, our merchant, this is the variable, it is not encoded, because when we are going to fit a regression or a logistic regression or a classifier problem, what will we do? What will the regression do with this electronic or the restaurant? These are text, right? Regression will not operate on a text value. So we have to convert this into numeric values. We have to convert this type, merchant types, into a numeric value. How can we convert it? We can convert it in a way that we can give merchant types. So suppose we have electronics. We can give electronics as 1. We can give fuel as 2. We can give luxury as 3. In this way we can encode. This is called encoding. Providing the categories are unique number or a different number. Providing all the categories a different number, this is called encoding. So we will do that encoding in Python. Okay, we will provide electronics the number 1, restaurant as number 2, luxury as 3, fuel as 4, in this way. So for that, what library will be required? We will be required the library label encoder. So let me go to the code. What is this code to encode? The code to encode this label encoder is you have to give label encoder, that is the library name. Then you have to write .feed transform. Then within a first bracket you have to give dataset name. What is our dataset name? Can anyone tell me what is our dataset name? DF. Very good. And our dataset name is credit card fraud detection data, but we have stored it into a new name called DF. That's why whenever we have to call it, we will call it by the name of DF. Then within a double quotation you have to provide column name of the categorical variable upon which you want to apply the encoding. Okay, so just let me write this label encoder. Label underscore encoder. Then I will write .feed underscore transform, and then within a first bracket I have to provide the dataset name, that is DF. Then within a third bracket what I have to provide? I have to provide the column name upon which I want to apply the encoding. So what is the column name upon which you want to apply the encoding? Merchant, not merchant exactly, it is merchant type probably. Yeah, merchant type. You have to give the exact name, otherwise it will not work. So the column name upon which you want to apply the encoding is merchant type. Give a double bracket, a double quote, and then end the bracket. You have to end two brackets. This third bracket you have to end, and then you have to end this first bracket as well. So end this first bracket as well, and your label encoding is applied. Your label encoding is now applied. Okay, so I am not running this cell yet, we will run it after. Now our label encoding is applied, right? That means our merchant type, variable of merchant type, now it doesn't look like the previously it was looking like this, that merchant type, previously this variable was looking like that, it was looking like electronics, then fuel, then we had luxury. This type of categories were there. Now our merchant type variable is looking like this. It is having the values in the form of 1 or 2, then 4, then 3, in this way. It is now encoded. Now should I replace this merchant type and store this merchant type in place of this variable? Should I do this? In the actual data, should I replace this previous merchant type having these text values with this merchant type having this numeric values? Should we do that?
Yeah.
Otherwise our modeling will not work, right? So for that we are going to send it back to the categorical variable. Okay. So to send it back to the categorical variable, here is the code. You have to give the dataset name, then you have to give the column name of the categorical variable, that is obviously going to be the merchant types. I am going to fit it into the merchant type variable, and then the code that we have written here, the encoding that we have transformed by writing this code, this is the same code that we are going to write after writing an equals to. So what is the dataset name? Dataset name is DF for always. And what is the column name of the categorical variable? That is merchant type. merchant type. Then we are going to assign an equals to, and after equals to we have to give this code, label encoder dot feed transform dataset name column name. This is the same thing that we have done here, right? So I'm just going to copy it and paste it. So here what we have done, just observe this code. Here we have applied label encoding to merchant type variable and stored that refined version of merchant type variable in the actual merchant type variable of our dataset. Here we have applied label encoding of the merchant on the merchant type variable, and after application of the label encoding, whatever we have received, we have sent that merchant type variable in the place of the actual merchant type variable. Clear?
Yes, sir.
Now I want to see my data. Let me see my data now. So I am just writing df dot head and 10, and let me run the code so that we will get the idea of the data. Merchant type, was there any spelling mistake? Name error, label encoder is not defined. Oh, I have might done a spelling mistake here, sorry. E should supposed to be in capital letter.
Sir, why we choose a label encoder?
Label encoder is a library which is being chosen just to fit the encoding on the categorical variable. Merchant type is a categorical variable which have text values. So if we have to convert it into 1, 2, 3, 4 in these values, we have to encode it. For encoding it, we have to choose label encoder. Label encoder is supposed to be in E, should be in caps, otherwise it will not work. Yeah, now it will work. What? Label encoder is not defined. Label encoder. Label encoder. Label encoder is supposed to be defined now. From sklearn.preprocessing import label encoder. Label encoder, no spelling is correct. Preprocessing.
Sir, in import, we don't write a slash.
Why have I written a slash? Where?
First,
Where have I written a slash?
between a label and encoder.
Yeah, I haven't written any slash. Oh, acha, you are telling in the below portion. Have I written any slash? Oh, acha, right. Actually, it was coded from the top. That's why the mistake happened here. Yeah. Label encoder. Here also I have given a. Okay. I hope it is fine now. Yeah. Missing one required positional argument. Why? Column name. Label encoder dot feed transform df merchant type error. Okay, missing one required positional encoder dot feed underscore transform df merchant type. Missing one required. How doing it in a single code will it work? encoder missing one required positional argument. Why? Where is why? Can't find any why. Label encoder dot feed transform. Can we store it into something LE? And label encoder dot feed transform missing argument. Why? Just give me a minute, okay? Label encoder dot feed transform missing one required positional argument. Why? Merchant type is the spelling correct? Merchant type. Yeah, it is correct. Let me write it again. df is already loaded, so here we have to just give the name merchant type merchant underscore type yeah.
So,
Yeah,
I think there will be a single hyphen instead of that equal sign. You can use that also. Here in the number 4th line, here it's LE equals to. You can just
now if we
use a
don't
single
even use this LE, it doesn't make any change. Dot feed underscore transform. Positional argument missing one required positional argument. That is y. Where is this y coming from? Okay, label encoder, I think it might not be there. Let me just load the label encoder and then try. I am loading it into E. Label encoder, bracket open then closed, and then I'm going to dot feed by E dot feed, and then if I apply it, yeah, now it is working. Yeah, right. Let me just tell you what has happened here, but before that let me just correct the code properly. Yeah, so label encoder was not working because we haven't stored it into any name, although this is not required for pandas. Here today I haven't assigned any alias or nickname to pandas, so pandas work fine with it, but that is not the case in case of label encoder. Label encoder doesn't work if you don't assign a name to it. So here what am I doing? That I am assigning a name to the label encoder. I am assigning to a name to the label encoder, and then the name is E. Then by the help of that E dot feed transform, that is the same thing. I am writing E dot feed transform, then the merchant type variable, and then if I want to see the first 10 columns or first 10 rows of our data, you can see that this is the first 10 rows of our data. The same thing that we have done, just the difference that was being created, that was we have stored label encoder into a name. I think I have found the mistake that was I doing, that I wasn't giving these brackets when I was doing the code. If I don't do it and just keep it as label encoder, then brackets, will it work? Probably it should work. Yeah, it is working now. So the mistake that was happening, that I was making again and again, that I was not giving these two brackets. I was just writing label encoder then dot feed transform, but these two brackets were missing. These two brackets were these two first and first brackets were missing. Okay, that's why our code was not working. So you have to give these two brackets. Okay, and now it is, everything is fine. Here you can see our data. Now can you find fuel or electricity or anything like that in merchant type, or you can just find the values 1 2 3 4 5 6 0. These are the numeric values. So our merchant type, which was a categorical variable, is now being encoded by some numbers. We have provided unique numbers to each category, and our merchant type variable is now encoded by some unique numbers. Clear? Clear now?
Yes, sir.
Should be in label encoder. So the mistake that I was making, that was I was not giving this label encoder and this brackets. That was the mistake that was happening. Now we have to check the ratio of 0 and 1. So what was the ratio in 0 and 1? To check the ratio of 0 and 1. Now what was going to be our dependent variable? Fraud is going to be our dependent variable. We want to predict that whether the credit card transaction is a fraud transaction or a genuine transaction. Fraud transaction means the credit card holder is not doing that transaction. Someone forcefully or unknowingly is taking the money of the credit card owner. That can be by the way of sending a link to that person, or that can be by stealing the credit card of that person. It can be in many ways. So we want to check that how many zeros are present in this fraud variable and how many ones are present in this fraud variable. Now why is it important? I will tell you that why is it important to check how many zeros are there in the fraud variable and how many frauds are there in the how many ones are there in the fraud variable. But before that, let me check you the code. So what is the code to check the number of zeros and number of ones? If you want to count out the number of zeros and number of ones in any variable having the values of 0 and 1 only, this is the code. You have to give the dataset name. What is the dataset name? In our case it is df. Then within a third bracket you have to give a column name. What is the column name? What is the column name upon which we want to check out the 0 and 1? That is fraud. So we will just give fraud, then double quote, and then we have to just give dot value counts. So this is a very simple way to remember the code also. If you just memorize the format that is written here, you can just remember the code also. So how many zeros are there? 667. And how many ones are there? 333, right? Are you getting my point? How many zeros are there? 667, right? And how many ones are there? 333. Now, do you think that real life, what are you going to do with this model? You are going to sell this model to a bank, right? That bank can feed this model and see that whether their credit cards are, the transactions made by the credit cards are fraud or not fraud. Now, do you think that real life banking problems face this type of situations where this amount of frauds are present? 333 are the fraud, almost 33% are fraud. Out of the total 100%, 33% cases are fraud, right? So do you think that real life scenarios or real life data looks like this type of? What do you think? Does this amount of fraud happens in real life, or very less amount of fraud happens in real life? More amount of fraud, more amount than this. If you take 1,000 cases, what will you think? I mean, how many frauds will be there in the 1,000 cases? If you take 1,000 transactions, how many frauds will be present in those 1,000 transactions?
70 to 80%.
Out of 1,000 transactions, you will find out 70 to 80% fraud transactions.
I think the transaction of fraud is very low, like 10 to 12% in real life.
Okay. Look, if you take 100 cases, the amount of transaction will be probably 2 or 3 or 4 that will be fraud. So the fraud transactions are very less, na? I mean, frauds are happening always, but it is not like that it is in a huge amount that almost every transaction is a fraud. It's not like that. Very less amount of transactions are fraud. So the ratio of the transactions which are fraud are very less. It can be 5% or it can be 6% or like that. So we have to extract the data from here. What we will do? We will extract the data from here. Okay, and we will extract the zeros at first, we will extract the ones then, and then we will take 95% 0 and only 5% 1 in our data. In our data, we will take 95% 0 and 5% 1. 95% 0 means 95% of the transactions are safe, genuine, and 5% of the transactions are 1 means these are 5% of the frauds. So which model will be appropriate? If we have applied the model on this data, will that be appropriate? Or if we have applied the model on this data, that should become appropriate. What is your opinion? What do you guys think?
Last option.
The second option, if we feed the data, it will be more appropriate, right? So at first in the step 1, we will extract the zeros, then we will extract the ones. So to extract the 0, what is the code? You have to give the variable, the dataset name, that is df. Then within a third bracket, you have to extract the variable. You have to extract the variable from the data. What is the variable? The variable is fraud. So I will just extract the variable fraud, df dot fraud. And then I will close this third bracket, and look, this df fraud is basically you are extracting the column, and this df means you are again putting it back in the data. This df dot fraud means you are extracting the fraud variable from the df, and this df at the outside means you are again putting that fraud variable in df. And then I will apply the condition, that is equals to 0, as I am extracting the zeros here. So you have to give double equals to then 0, then I will close the third bracket. So here what are we doing? We are taking df fraud, that is the fraud variable from data. We are just taking the values which are 0, and then we are again putting it back in df. Then we are again putting it back in the df, that is the entire data. So what are we doing here? We are just taking the 0 values. Okay, and if I want to store it into some place, then I can store it by assigning a new name. I can assign it a new name as df underscore 0 equals to. Okay, same goes for df1. If I have to extract the ones, the code will be same. The code will be absolutely same, just that 0 will be converted into 1. And now I will take these zeros and ones into a fraction. I will take 95% of zeros and 5% of 1, so that our model is much more realistic. Okay, so that we can sell this model to any banking platform by the help of real life proper data. So I will just do that. 1 minute. Let me just stop this screen recording, so it will be off.